Michael?
Yes, I posted them. Do you not see them?
I hadn't had a chance to look. I just wasn't sure. You, on the same time zone as me, might not have seen them either.
I saw them during the first session, I think, and posted them. Okay, let's go ahead and get started. By my clock, we're at the top of the hour. So, welcome to LAMPS. This is the last session for today at the virtual IETF meeting. And remind you of the note well. These are your obligations if you want to contribute. Please make sure that you've reviewed this. And I want to highlight on the next slide BCP 54, the Code of Conduct. Remember that we're here to work on standards for the global internet. That means a diverse technical and environment and operational environment. And we're going to do that being courteous and respectful to each other. We're going to have impersonal as opposed to bullying or attacking attacks. Rather focus on the technical issues. And please be prepared to contribute to the ongoing work of the group so that we can reach consensus and get done. So the agenda for today is pretty full. So let's make sure that we be concise and focused. This is the first slide of the agenda. Here's the second one. So the first question is, are there any agenda bashes? Okay, hearing none, we'll turn to the status of the documents that are with the RC editor or the ISG. The first one is LAMPS RFC 7299 update. This is in the RFC editor's queue. There's really nothing to report here, therefore no slides. It is really just registering two object identifiers, and by the way, that has already happened. Ayanna assigned them, and pointing to this document that is in the RFC editor's queue. So we'll probably see an RFC out of that in a month or so. We're now ready to go to the Cmp Algorithms update. And I think, Hendrik, if you'd come to the mic, I'll share the slides.
Hi, everybody. So this is the Cmp RFCs or to-be RFCs. I split my slide deck into two because this draft is already advanced a little bit. So next slide, please. What happened since last IETF? We fixed some minor formatting nits. The document proceeds to working group last call. Russ provided his feedback, and also Roman provided an area director review. Thanks to that, I think we discussed or tackled most of the comments from Roman on the list. I will have some slides on section 7, which may need some little more discussion. Next slide, please. So section 7, what is it about? The introduction to section 7 provides some general guidelines for implementers on how to choose a set of algorithms. we advanced the text a little bit, and on the next slides I will propose also an additional table to explain what a balanced set of algorithms would be. Section 7.1 updates RFC 4210 Appendix D2, which is an algorithms use profile with a set of mandatory to implement algorithms for the PKI management operations specified in Appendix D and E of RFC 4210. These PKI management operations focus on managing person certificates. That was the main focus back in that time. For example, the initialization requests for a signature certificate and an encryption certificate, where the encryption certificate could be supported with a centrally generated private key. And these profiles use encrypted value, even though we propose to switch to envelope data for providing centrally generated keys. We thought that for these profiles, for backward compatibility, it is okay to stick to encrypted value here. And therefore the section 7.1 uses the algorithm identifiers also used in these appendixes, and are also focusing on usage with encrypted value ASN1 types. Section 7.2 uses or lists the algorithm identifiers provided or introduced in Lightweight CMP profile. Lightweight CMP profile utilizes envelope data for transferring centrally generated keys, and section 7.4 does not specify any mandatory algorithm sets, but just explains for which algorithm identifiers which kind of algorithms from this document could be used. That was kind of decision we took last IETF. Having that said, for this introduction, next slide please. Sorry, one step back. In RFC 4210, Appendix D2, in this algorithm use set from RFC 4210, some outdated algorithms are listed. And in section 7.1, we propose to deprecate use of some of these algorithms specified in 4210. Especially MD5 and SHA-1 should be deprecated. DSA, I think, is not really a good choice if you look for interoperable implementations. That is also something said in SP 800-57 Part 3. Therefore, we would also propose to deprecate that. RC5 and CAST 128 should also be deprecated from our point of view, as well as triple DES, even though usage with 3 keys, it is already deprecated as of NIST SP 800-131A. With regard to password-based MACs, we do not deprecate it, as it is specifically introduced in CRMF and used in CMP quite widely. And we just introduced this year an alternative PBMAC1 in the update RAS provided to CRMF. And therefore, we keep it or propose to keep it as an option, but state that it is recommended to use PBMec1. Are there any comments on this slide on deprecating algorithms? Yeah, Sean, please.
Great, good job. Let's do it.
Okay, thanks. Okay, then next slide, please. This is the updated introduction of section 7. So Roman commented that the current section 7 introduction was too brief and not clear enough. We worked on that, and I even provided some further update. So in this introduction, we said, okay, the first first argument for cryptographic strength is the algorithm and key size or key strength of the keys and certificates that are to be managed using CMP. And all other algorithms used in this PKI management operation should be at least as strong as those keys that are managed. Finally, of course, the algorithm set is as strong or as weak as the weakest algorithm in a set of different algorithms. Then the message protection consists of 3 different parts. So typically CMP protection is either MAC-based or signature-based. Therefore, the entropy of the shared secret information, of course, is quite crucial, but also the key and algorithms used for signature-based protection. If central key generation is used, then of course the protection of the centrally generated keys is crucial, and therefore on the one hand the key management technique, and on the other hand the symmetric encryption of a content encryption key or of the private key is crucial. But finally, to avoid to overconsume resources of the devices, it is recommended to make use of an algorithm set that is kind of balanced. And examples for this I would like to provide or give an example on how to provide this on the next slide, please. So this is a approach we discussed in the group of editors. This focuses on the bits of security in the first column, and then the key size or algorithm of the keys to be managed. In the next column, there is CMP protection, which is indicated with these 2 algorithm identifiers. The next, which is typically signature-based or MAC-based protection. The next 2 columns focus just on central key generation, where we have 1 column on key management techniques and 1 column of key wrapping and symmetric encryption. So this could be one table to add to section 7 introduction, which kind of points out what balanced set of algorithms could mean with regard to CMP usage. Next slide, please. This is an alternative proposal. Looks a little bit leaner, maybe is not fully complete, but this does not focus on on the parts of CMP PKI management operations, but on kind of algorithm types, and therefore would need to be kind of applied on CMP usage then. So the question from the authors would be, what does a group think about adding such a table to section 7, and which table would be preferred? Roman proposes to take both. We could do that, of course.
Well, I think the table is helpful. I think the one that fits best in ASCII art is the one that makes the most sense, but
that will be a special.
So I leave it to the editors. Exactly. Roman says use SVG.
Yes.
Yeah, but it's, you still have to end up creating an ASCII version at some point. Sean, then Deb.
Yeah, hi. I just wanted to echo what Russ said. I think it's a good idea to put this in. I think this is an entirely sane approach to kind of make it matchy to line up the bits of security with the algorithm. So I to which one you should include, I'll leave that to you.
Okay, thanks.
So unless you can reference something that already has it already laid out in a nice table like that, I don't know whether NIST has anything like that. I don't know whether you have access to anything like that.
We have references to NIST and to eCrypt, which has some input which we already used. There is also some similar approach for, I think, using named curves with X509, which we also used, but there are some more algorithms. We actually didn't find a proper complete source for such information.
I'm hearing that everybody thinks the table's a good idea and that they leave it to the editors to figure out how to do it.
Okay, thanks. Then we will go ahead, and I would propose an update or submit an update of Cmp Algorithms, hopefully by end of this week, incorporating the changes, the proposed tables, and would be happy to get feedback also on the tables if there is something we did not catch or specify correctly. Okay. And this is it. Oh, maybe there is one next slide. I don't know. Was there something?
No, I think that was it.
Okay, thanks.
Okay, DKG, is there anything to say about samples? Go ahead.
Can you hear me?
Yes.
Great. There's been a review just this past week from the area directors, which identified a few minor textual changes. I'm actually about to reply to that on list. I don't see any concerns with the I think it's moving forward in the larger review space now.
Okay, Roman, go ahead.
Kind of clarify, the document's in really good shape. It's actually an IETF last call already.
Okay, very good. All right, so I saw that there was one I don't know, error or something in one of the formatting, but good to hear that we're getting more eyes on it. Okay, so the next thing on the agenda is the CMP updates and the single slide deck for that and the lightweight profile. Okay, Hendrik, you're back.
So here I'm. So this is a slide deck on CMP updates and lightweight profile. Next slide, please. So what happened since last IETF on CMP updates? So thanks to John Gray's intense review and very valuable comments and good discussions in the last weeks, we added him to the list of authors. So thanks to John. We fixed erratas on 4210, which were in the backlog, and mainly minor editorial nits. We moved, as discussed, the #algs field in the third conf message to the end of the structure. We added a new CRL update retrieval support message to CMP update, so introduced a new general message type finally. And due to this containing the relevant input in the request message, we also changed the root CA cert message, where we, as of back then, we contained or transferred the old root CA certificate where we request an update for in the general info field, and we switched this to transfer it in the request message, in the body of the request message. We extended as introduced or asked last IETF, we wanted to extend the polling mechanism in CMP. Currently, 4210 offers polling only for enrollment messages, and we had the requirement to provide also kind of handle delays for all kind of messages. And last IETF we sketched one approach, and we worked on that also with discussion with John, and proposed an update on extension of the existing polling mechanism. I will give details on the next slide on that. So we updated the version handling. We shifted some security considerations to from lightweight profile to CMP updates. We edited some nits in the ASN1 module, and we switched from or reworded from transport to transfer, mainly in the section 6, as this is more appropriate when talking about HTTP or CoAP. Next slide, please. So what else is to do? In CMP updates, we need to register OIDs for the new CRL update retrieval. And as we changed the root CA cert update mechanism, we would like to reorder some of the pre-registered OIDs, but I don't know whether this is possible. If not, of course we can stick to the ordering as of today. But maybe, Russ, we can.
What do you mean by reorder? Change the values?
Yeah, we have I think 6 OIDs registered already, and we would kind of rename one and place it and switch the places of 2. But I
If you
can
mean,
send
yeah, but what you mean by switch the places, if you mean where they appear in the
the
ASN1 module, that is fine. Change the bits that appear on the wire, I would object.
okay. Understood. So
Okay.
we put this our proposal for the ordering of the OIDs in the draft, but if you say changing the values is no good idea, then we can stick to what we have.
The point of getting the early assignments was to not change them, right?
Yeah.
Yeah, exactly. Okay.
No problem.
I don't want to dwell on that, but we have a lot of stuff to go through here.
Okay, so next slide, please. So lightweight CMP profile, what happened since last IETF? So mainly we specified all that what we prepared in CMP updates in more details and profiled in the lightweight CMP profile. We also added references to SZTP, CSR, and Brisky AE to the lightweight profile, to the introduction mainly. We updated this root CA cert update retrieval mechanism. We simplified at one place the sender recipient nonce handling together with delayed delivery, so with polling. We added this new support message on CRL update retrieval. We generalized this delayed enrollment to a delayed delivery for all kind of messages, and also updated with this regard the end entity state machine. We updated section 6 little bit with regard to delayed message transferal, and also with the wording topic switching from transport to transfer where appropriate. We moved some security considerations as said, and we edited some minor topics like capitalizing PKI. Never mind. Next slide, please. This is the approach we specify in the current draft CMP updates and in more detail than the lightweight profile. On the left-hand side, you see how polling works today, just for enrollment messages, IR, CR, and KUR. And on the right-hand side, the updated version, it also works for the other message types used in the lightweight profile. The mechanism is for in an IPCP KUP message, we can have a waiting status in the certificate response body. We do not have this in other types of messages, but we could send instead an error message which can transfer a status waiting. Doing so, the polling would be initiated for the non-enrollment kind of messages with this error message containing status waiting. And then the polling mechanism kind of goes as usual. For enrollment, the certificate request ID in the poll message is the one of the certificate request, of course. For all other messages, it's the -1 as poll certificate request ID, which is also available today for those cases where no certificate request ID is available in the request message. And then the polling mechanism goes as currently, also as usual, no further changes needed. So the only thing we added mainly is to introduce the error message with status waiting to initiate polling for non-enrollment messages. Any comments on this?
Seems okay to me.
The next slide, please. This is mainly what was discussed on the mailing list. So introduction of 2 new general message types. One, the request message providing a status of a CRL, which contains more or less a pointer to a source and a timestamp of the CRL. And in the response message, then an updated CRL or no update if there is no more recent CRL available. Next slide, please. What needs to be done from the text is kind of complete. From one feedback from Roman, we need to do a minor or little update in section 4.1.6.1, which is the key agreement, key management technique for centrally generated keys. But that's it for the moment. So this is it with the presentation. Any comments?
So my big question is, does anyone have concerns with going to working group last call when the author, after the authors make the next update? Okay, I'm not hearing anyone, so let's plan to do that. You guys make the changes that you've talked about here on this slide, and then we'll do the call. Do you have a preference for an order, or do you want them to go together?
I think it's best to take CMP updates first. Finally, this is the basis of syntax changes, which is then used in the light-wide profile. Therefore, I think this is the best order. Anyhow, all 3 drafts kind of are interrelated. So I would propose not publishing any of the 3 before review of all 3 is done, just to be sure that if something pops up which has effect on the other drafts, we did not publish too early.
Okay, that makes sense to me. Anyone else have comments on these 2 documents? Okay, then we'll start the working group last call after you do one more update.
Yeah, thanks. Great.
And now we'll go on to the next presentation. I think DKG is doing the speaking on the header protection. I'm not seeing it. Why not? I uploaded the slides, but I don't see them. Let me do it this way then.
now.
Okay, go ahead.
Hi, folks. Sorry for being offline for a second there. So the LAMPS email header protection document has been stalled. Next slide, please. Recap for folks who haven't looked at this in a while. The draft specifies at least two major options for how to protect headers in signed messages and encrypted messages. And it's been unclear how we select from them about what guidance we give for generating encrypted or signed messages. In the last round, we proposed a list of criteria about specific problems we might see, and we got basically no feedback. So next slide, please. This presentation, I basically just want to suggest a way to get unstuck and see if folks have other suggestions for how we might get unstuck. I think one of the things that we've been seeing is that of the proposals that are specified, any of them will work for new clients that all cooperate. And the concerns we've been stumbling over is what happens, how protected messages are handled by legacy clients. I see Bernie in the queue. Bernie, you want to jump up?
Okay, this is Bernie Höneisen. Yeah, I pretty much agree with the statement Daniel made. And I've been thinking about the way forward, which I would like to throw into this discussion. Not necessarily that I'm fully behind that, but to summarize, we have no clear winner in a way between the two, between the legacy, between the wrapped and the injected message scheme. There is sometimes the wrapped and sometimes injected scheme is better. So to change the standard, this is basically a two-week argument if we change the standard from wrapped to injected. In more detail, if you have signed and encrypted, the current standard, the wrapped prevails. It's overall better than injected. And it's easily fixable because it's minor issues. Basically need to tell the clients to avoid that the user has to open an attachment. In signed only, it looks a bit different. There we make the difference between S-MIME capable and non-S-MIME capable clients. In S-MIME capable clients, the two schemes, they are more or less equal. In one, you have to open an attachment. In the other one, is only the unprotected subtext shown in the injected. So this is kind of balance. I don't see any kind of prevailing in here. For non-S-MIME clients, in case you have a client that doesn't understand any S-MIME, but only there and only in the multi-part scheme, the injected message scheme has some advantage because you can make, in this scheme, you can make or reach more, let's say, more recipients that can actually see what you write. Based on that, I suggest to discuss about some compromise, which would basically be go on with the current standard, which is wrapped, not change anything here except clarifying and help fixing those clients that do require showing attachments. However, to help clients which are just described, like legacy clients that don't understand S-MIMEs, allow an option to use the injected message header scheme with multi-part signed, but this for signed only message only. The default for all would remain wrapped, but for this case, we would introduce the injected message header scheme. I'm not sure whether this got a bit clear, but I think that could be a way out of this situation. And open for comments here.
So thank you, Bernie. That's a useful suggestion. It would be great to have that in writing about what we specifically want. A proposal about how to move forward there. I actually have a different set of. So my concern about sticking with the standard as it's written, which is not currently implemented, is that people have not been implementing it for some set of reasons. And one of the reasons, I think, is that people are afraid of damaging how their messages show up on the other side. So I wanted to propose a different, in particular to legacy clients. And when we say it's easy enough to fix, I agree with you that I don't think it's actually, these are hard problems to fix in mail clients, but we haven't seen folks fix them. And so just saying we just need to specify it better is troublesome. So let me, the slides actually have a separate proposal about how to evaluate these things that I think might be useful. Can we take the next slide? And I'm hoping to hear some feedback from the rest of the working group about how we do this. So this is a proposal. This is my proposal for how we think about evaluating these. I think we could, in this proposal, aim for minimizing any change in experience for legacy clients. That is, a legacy client shouldn't be able to really notice much of a difference between what they're doing right now with regular emails that have no header protection and emails that do have header protection. So minimize the change in experience. And that means also ignoring any security increase for legacy clients. So if a legacy client could get a security increase by doing some additional, with one of these schemes, by doing some additional workarounds or interaction with the message, and that gives you some sort of protections. I'm proposing here that we ignore security increases for legacy clients. And if you go to the next slide, let me explain why this is the proposal, why I'm proposing this. Next slide. Can I drive the slides here? There we go. Okay, the rationale is I want to incentivize clients to adopt this. So we want to give clients that can adopt this a reason to adopt it. That is, give them the security benefit once they've adopted it. And hopefully this set of decisions will break us out of the existing logjam, which is we have a specification, nobody's implementing it. I think people are rightly concerned about what it will do. And so if what we do is we say, hey, look, if you adopt this, your messages are going to get through just as likely as they are before. If you implement it on the receiving side, then your users get additional security benefits. So it gives a clear incentive on both sides to adopt. And hopefully that would break up the logjam. So next slide, please. Right, so that's my proposal. And we can run down what we think the outcome of that proposal would be. I mean, I have some guesses at it, but I think it comes close to some of what Bernie is proposing in terms of allowing different mechanisms.
I think you're partly right, but partly it's because the document contains two approaches that we haven't sent a clear message to the community of what they should be implementing.
Right. So what I'm referring to is, so Bernie's claim earlier, what he just said was, this doesn't warrant changing the standard, right? I think the document takes as a starting point the idea that, I'm forgetting now the number of SMIME that said, oh yeah, here's how you protect headers, you just wrap a message. That has been around for a long time, even before this document was present, and no one adopted it. Right? People had the mechanism to do it, and I think people were concerned about doing that. Maybe they were just lazy. Maybe people don't care about the mail user agents anymore, in which case everything is hopeless. But maybe they had good reason not to adopt it, and the main reason I could see was the effect on legacy clients.
Right. Well, the previous one was basically just use RC822 message, right? Encapsulate the whole thing.
That's right. And people didn't do that, right? Very few
people didn't do that.
Actually generate those.
Right. And I think it was the UI, the fact that it looks like a message inside a message. But that's my guess. I'm not an implementer. I'd love to hear from an implementer.
That's my guess as well, and that's why I'm proposing that we can reduce that fear by picking a standard that will reduce the minimize any experience for legacy clients in terms of changes from a non-header protected message?
Bernie?
Right?
Don't fully agree with the conclusions here. I think like having a message in a message that you can click and view is not the issue. Having a message in a message that you don't see, like that you just see garbage, I think this is the issue, just to make that clear.
I think both of those are issues. Michael?
Michael?
So we have existing experience here with the RC822 message wrapping that Mailman does for DMARC, right? We submit this in the IETF lists, and some other lists that I run done this. And universally, confusers, the less technical the user, the more they're confused by this. So that message attachment really is at this point, a serious non-starter to me for older clients. Now, if you're going to tell me that that does not apply to the latest version of Outlook, then I say, go ahead, let's do it. But it's primarily these most vulnerable users that don't seem to understand what's going on.
Do we have any implementers who want to share their experience? Go ahead, Bernie.
What here is missing, like what I said, is that it's easily fixable, this message in message thing. And if we give instructions how to fix that, I believe like Microsoft Outlook could fix that. And then we have a big proportion of the clients of the user base that has a fix for this. So this really easy thing. And if you do this other scheme, the injected scheme, it's more difficult to fix or more difficult to implement because the instructions are not anymore so clear, straightforward as for the wrapped scheme that is currently standardized.
Do we have anyone from the Outlook team who has committed to fixing it? I'm concerned about really like claims of really easy to fix coming from someone who's not working on the client.
I guess that means no.
Right. So that I mean, claims that things are easy to fix by the implementer is different from claims that something like is actually going to be fixed. And I tend to agree with Michael's concern about I think you coined the term confuser there, but the confused user is a risk that people are grappling with. So I recognize that one of the pieces that are in the current. So let me just outline a set of ideas that come from the proposal for how we might try to break up the logjam here. It looks like we don't have anything that really addresses the problem of for encrypted messages with protected headers that include confidential subject lines. They end up with either an attached message, or they end up the legacy display, or the subject line is totally invisible, or the legacy display option doesn't render well on some major clients, in particular on Outlook. So none of those proposals actually seem to fix, seem to meet the goals that we laid out. So, there's another approach which we could do, which says we're going to solve the problem for messages that are text HTML, where we don't introduce the legacy display. We use a wrapped message approach. Sorry, not a wrapped message, but an injected headers approach. So there's no additional attachment, and we say that HTML generating mail user agents should include a div at the top of the HTML with a particular attribute that they put the obscured headers, in particular the subject header, in that obscured attribute. And then a mail user agent that's capable of, that's compliant, can hide those divs. that it can avoid rendering those divs because it can identify them correctly. There's no additional attachment. And people who are rendering the message in HTML form who are in non-compliant clients will actually see the subject in the HTML rendering. So that seems to me to give as close as we can get to the scheme that's described here, which would mean dropping the legacy display proposal and minimizing the amount of sort of MIME shenanigans that are going on. So I'm happy to write that up as a variant of the draft and see what people think. But it looks to me like that might be something that would break out the logjam here, right? We could settle on injected headers, drop the legacy display proposal, and include this variant for the HTML for HTML specific messages that would degrade nicely.
Okay, Bernie, then Michael.
So two things I would again like say, confuse the user is with any proposal we use, we are confusing the user in some way. And the other thing is what you propose. I'm not quite sure that I understood it correctly, but is this something pretty close to what PEP has implemented as a PEP message format 1? Basically just add on top of the text, add the subject line, or on top of the HTML, add the subject line so that it is visible by a legacy client. This question for clarification.
Yeah, that's actually what I was inspired by, Bernie. It was early work by PEP.
Okay, then I understand. Thanks.
So can I ask, is the do nothing situation? Does it result in the wrapped message? Is that what I understand?
The do nothing situation would be that we keep the standards as they currently are, which says use this wrapped message, and no one implements them, as far as I can tell. Which means we give up basically on people actually protecting the headers of their messages. So
sorry, I don't mean the do nothing in terms of not protecting the headers. I meant not doing anything to accommodate legacy clients.
If we don't do anything to accommodate legacy clients, then any of the proposals that are present in the draft seem plausible. But I think that one of the reasons that we're struggling here is because people are afraid to emit messages because of their interactions with legacy clients.
So just to be clear, these are encrypted messages, not just signed ones?
They're both.
Okay, because
we don't currently protect headers either signing or encryption.
Encrypted messages typically have to go to somebody who actually you have the identities for, right? Or you can't encrypt. And so there's a possibility, in theory, of some negotiation where signed messages go to mailing lists and other places and people that aren't ready. And so there's, a different analysis that I think matters. And if you're signing it, then you're not necessarily caring about disclosing the subject line because you just signed it. Okay, you might be care about making it integral. Okay, the meeting is on Thursday, not on Wednesday, as someone fabricated, and so maybe repeating it is sufficient. That's enough accommodation in the signing case. And it sounds to me like we just shouldn't do anything to accommodate legacy clients in the encrypted case. That's sort of what I'm thinking.
So the injected headers approach suggests that we don't do anything to accommodate legacy clients, and the result is that legacy clients will render the message as though it had no subject. That's without the legacy display section.
Right.
The wrapped message situation says we don't do anything to accommodate legacy clients, and the result is an encapsulated message, which some clients will render one way or the other. And I'm a little bit reluctant to say, screw all the legacy clients. If you're having trouble sending an encrypted email to them, you just can't expect that to work at all, even though they're running a tool that claims to be SMIME compatible. Because the user will end up with an encapsulated message, and then they have to do something to view that message. And then when they reply to that encapsulated message, they're not operating in an encrypted context. There are a bunch of situations there that make me pretty nervous, right? If we say, here's how you generate a message, and we know that that's going to cause problems in, say, encrypting replies, that strikes me as a pretty risky gamble.
I'm going to say that I don't care that much about legacy encrypting clients because they're so rare at this point, alas. And so let's just move forward on that. On the but you're telling me that in the signed case, the user might have an empty subject, even if it's signed.
No, I'm not saying that in the signed case.
Okay, so then I would say in the signed case, I really hate the encapsulated message. And in the signed case, I really don't want to do that. And I am agnostic as on the encrypted case for whether or not it's encapsulated or not.
Got it. Thank you for registering that.
That just like is pretty close to what I proposed, that we distinguish between signed and encrypted, and we would allow something to make the signed case legacy clients better, and in the encrypted we just go forward with the much easier case as currently standardized, if I understood that correctly.
Okay, what I think we need to do is see this written up, and I think the easiest way to do that is probably just to modify the header protection draft to implement the choice you're picking here, and then we can do last call and see if we get agreement. I did have a commitment from a manager at Microsoft that they would pay attention to the last call, so hopefully we'll get their feedback at that point.
Okay. So Bernie, sorry, go ahead, Bernie.
I wasn't clear if we have like a consensus here already. I'm not too sure about this.
I'm not either. And Bernie, maybe what should happen is you and I, and maybe Alexei, if he's willing to join in, should have a meeting sometime next week to look at some proposed changes and see whether we can agree that those are worth putting up as last call. We won't find out the consensus until we've given a concrete proposal, I think, to the group at this point.
I think that's the case. Okay, DKG, you want to say a few words about mail guidance? The meeting's already half over, so we need to pick up the pace.
Yep, sorry. Little to report on the end-to-end encrypted mail guidance draft. There's a bunch of fixes in the draft. I'd love to hear some suggestions from other implementers about things that they've noticed or things that they've read in the draft that they think are wrong. We've been pretty much stalled since the last IETF. I hope to get it unstalled. Participation would be great.
Okay, thank you. So that's a plea for review.
Yes, it is.
Okay.
And contributions.
Yeah. All right, Sean, I think you're next.
Hello. I want to start off with an apology for publishing this document last night, super late. But I would like to thank you all for getting up super early and reading it already. I'd like to note that my co-authors are actually online here. They're here. And so they should feel free to jump in if they have anything to add. So this is just a kind of an update of what happened with our document signing EKU draft. Next slide. So basically what we've done is we've made changes to the draft based on either direct or implied comments that we received on the list before. So the first thing we did was we clarified what document signing is, mostly to address the concern that the definition wasn't technical enough. And it's basically just adding more words around what it means for, the document is digitally signed contents that are consumed by humans, that as opposed to them being just processed by machines. We added a new section with lots of new text to address concerns that the handling process was undefined, and to address concerns that an EKU as a policy identifier was the way to do it. So the way we did it was we basically said there's an example in there for how to do it, and it kind of walks through how you would do it. And the example is based on the RFC that Russ wrote, which is how to digitally sign internet drafts. And so it kind of walks through the, what you would do.
It's 12 o'clock.
Sorry about that. And the basic plan is that you have the implementation examine the extended key usage values. And if there's no restrictions, then it's happy to use it. And if there are restrictions, then it can block it. Now, the way you can implement that is with something that's very similar to the certificate policies, constraints, and name constraint stuff with the excluded and permitted EKUs that a relying party is perfectly happy to implement to make decisions one way or the other. And then the last set of changes were just to kind of add more text and security considerations about cross-protocol attacks, and to note that there are really no privacy considerations added as a result of this draft. I know that was kind of quick, but that's basically it. And so the next steps is the working group adoption call. We're getting lots of great comments, and so I snarkily suggested to my co-authors that if we keep going at this rate, we won't need a working group to adopt it, because we'll have all the comments addressed and we can just go straight to an AD to do it. But we are actually asking for working group adoption because we believe we've addressed all the outstanding comments at this point. And it's a starting point. So again, if there's things that we've got wrong, we're perfectly happy to, hand over editing and move forward. So I guess that's where we stand. Thanks.
Does anyone who's here, I noticed the most vocal person against this document is not here, so we'll take it to the list. But does anyone who is here have concerns? Okay, hearing none, we will revisit the call for adoption on the list.
Yeah, Russ, I just want to make sure that, I'm not trying to run past Ryan just because he's not here. So I appreciate you taking it back to the list.
Okay. Michael, you're up next.
I'm going to check my slides, or push the right button here. You're doing it. All right.
Yeah, if I could find them. There they are.
It's in front of my mouth instead of in my head. There we go. Okay, so this is about a new document, RFC 17, which is ESP and the CSR attributes part. Next slide. And we've collected 3 or 4 authors, and I think there might be a couple other people that have some opinions. So the story so far, 7030 was unclear about the CSR attributes. In the Brewski and autonomic work in Anima, we made some assumptions about how they could be used. And to be fair, Max Pritikin was an author of 7030 and of 8995, and he seemed to think that we were doing it right when we designed it. So I think we had some reason to believe we weren't wrong. And then it was pointed out that it was wrong, that it did not match the ASN1, and that the ASN1 was sufficiently complicated that some people said they didn't know blood, and I was partly in that list. We had a virtual intro meeting. There's the recordings. You can go back and talk about the original, look at the slides. And we created a design team to do some work. Next slide, please. And this is really the short of the proposal at this point. It's actually not yet in the document. There's been a long thread of discussion among the document authors, which has not quite made it to the mailing list for reasons I don't understand. I don't want to copy people's private emails to the mailing list, hoping that they will start again on the list. But the short of it seems to be that one of the proposals is that we essentially have a very specific call outs for the values of a couple of things that we need to do, and that we're not going to basically allow any arbitrary attributes. And yes, Bob asks, is that a typo? Yeah, it should be a generic name. So if it's a name, then it can only be a DN, but a generic name can be subject alt name as well, which is really what we're interested in doing. Did I write generic? Okay, so sorry, it was 11:30 at last night at night. But that's what we have right now. This document is not ready to be adopted. It is very useful to discuss it on the mailing list as to what the goals are and what other people might expect or think that they want to do with it. I'm not sure that I want to have a specific, here's the part that fixes my problem and everything else is screw that. I'm not sure that I want to do that, but maybe that actually is the simplest way to do it. It's the least number of things. We did conclude that we did not want to break from being backward compatible with what was there, even though most of the specific use needs are in a somewhat greenfield application. So we probably could cope with anything we liked. We could even cope with having a negotiation via MIME type if we needed to. So I think those are all on the table, but it's not clear that we need to do that. And I think that's the last slide. Next slide, maybe. No. Yeah, that was the discussion. Here's a squirrel eating his Tim Hortons. Sean.
Hey, sorry that this wasn't clear. I think maybe it would have been better back in the day if we had more people review it. I guess I'm concerned that you would just take the attribute and modify it. I think you'd need to define a new attribute.
Okay.
Yeah, because it's just.
I think that was proposed.
Like
I think that was what was intended. I think that was intended, that it would be a new attribute. Yeah.
Yeah, and if you think that there's a new attribute and you want to have specific things to call out because you need them, great, we'll include them. We can use some fancier ASN1 stuff to allow it to be extensible. So there's ways to do this. Yeah, so my attitude is feel free to make the changes that you think are necessary to get this to work with what you need to do.
I think the question is whether or not we want to have, a specific thing that here's the name, here's the 3 values that people wanted to specify. And if there are other attributes, then that's a future revision.
Right.
Versus being able to put any attribute with any value in the thing, which is what I thought we were going to wind up with in the first place. And as you say, there's some ASN1 that makes it all happy. I just don't know how to write it.
I mean, yeah, you could. We can find people to help with that, but including.
Well, I think we have enough people in the authors. They just, I don't think they're here. Dan's here. I don't think David is here, and I don't think the other author Owen is not here because it's the middle of the night for him.
Another alternative is to define those 3 things as attributes and just stick them in.
Yeah. Oh, as new attributes.
As new attributes, or look, because there might. I didn't look really closely at the options, but that some of those might actually already be attributes buried somewhere next to it, or and then
they
you
are.
Can just
the issue is whether you can put a value with them.
Right.
Right, and that's the part that where the existing ASN1 was unclear to non-experts. We thought we could, but it turns out that there's no value. There isn't a value thing there. But it didn't stop me and several other people from putting a value in because ASN was self-describing, and we thought we were doing it according to what was there, and even interoperating, pretty much, as far as I remember, we just we did it the obvious way, and the other says, well, I did it the obvious way, and we did it in the same way. So we could just record. That was essentially what we thought we were doing. We're just going to record this extension, or whatever you want to call it, in ASN1 so that it's actually clear that that's what we meant. And then these somewhat other proposals are showing up. Anyway, I'm hoping we'll have that the authors will be less shy about posting to the mailing list, and we can have a better conversation, Sean, that you can actually contribute to.
So, Michael, it sounds to me like you're ready to do one more spin, then a call for adoption?
Yeah, I think that's about right. I think, assuming that we can get people to talk, that, somewhere in January, I don't think this has to take very long.
No, I should hope we're done in March.
Yeah.
Okay.
I'm done.
All right. Okay, Sean.
Up again. All right. So this is a document, I guess, that I volunteered to write at the last interim, which was about how to put NIST's PQC Chem algorithm in a certificate. Again, I apologize for not getting this draft posted. The link there is to a GitHub repo. I will have it posted shortly. And since it's not yet in there, I don't have any IPR. I'm not planning on asserting any, et cetera, et cetera, et cetera. So the ID's content's pretty straightforward. I was looking around for drafts to basically follow this on, which we've done a couple of these. And so I picked RFC 8410. I think that's the right one for the ED 25519 stuff that drafted the kernel. Put the save curves into kernel, and I just basically follow the format. So the basic premise is to put the winners in there, then have an algorithm identifier that with OIDs with no parameters, and multiple algorithm identifiers per algorithm to count for parameters. That's what I have in there now. Alternatively, we could just use the NIST specified OID and then have another OID for the parameters, identify whatever the parameter choices are. Like Kyber has like 2 or 3 different sizes, I guess, and there's some others. And people can tell me what those would be. Then we have to say what other bits and certificates would matter. So the key usage bits are the ones that come to mind. Obviously, I think key agreement is the one that we'd include. I put in cipher only into cipher only as maze, and then I thought, well, I don't really know if you do this, but I put them in there anyways just to have a think about it. Then the format for the subject public key fields, and then we went ahead and I added one for a private key format just to be complete, because I think sometimes when we left it out in the past, it caused problems. And obviously, we'd have an ASM1 module to kind of wrap this all together for reference purposes for anybody that really wanted to use it. And that's really it. And so I'm hoping to.
I want to challenge your one assumption here that is must be key agreement. Didn't the RSA KEM use key transport?
Oh, jeepers! You know what? I forgot to check on that. You might be right.
I don't have it on my screen at the moment, but that's my recollection. I was trying to find it before you finished your presentation, and I didn't. It's RFC 5990, and it uses key encipherment, which is key transport. So I think that's the thing to debate. Probably should go to the list.
Yeah, absolutely.
Okay.
But that's basically the idea. So the option is the real, I think the points of discussion are how to specify this. And I think, whether it's one OID, where the OID equals the parameters, or whether it's the OID for a generic algorithm plus the algorithm, the parameters being another OID, is kind of the big discussion here.
Yeah, so, I think I like the no parameters approach myself. Mike, you're in queue.
Yeah. So chems don't really fit cleanly, right? They're a new API. They're not really a key agreement. They're not really a key exchange. We're having the same. I'm going to present in a couple slides about getting chems into CMS for content encryption. We're having the same problem here. Is it a key agree? Is it an exchange? Should it be its own top level structure? So maybe this will maybe those two drafts sort of need to sync. And there's probably going to be some others that crop up. Probably all need to choose a direction and synchronize on it.
Absolutely, I think because the draft with multiple keys would include the same things, and you'd have to indicate the usages for those individual keys. We basically have to agree, because if you pick one and if we have two drafts that pick different things, it's like a foot gun that we're firing off for fun.
Yep. Okay, John.
Yeah, how would this relate to the final NIST standards? Would this be, is the plan to start working on this and not published before the final standards is done, or would this be temporary OIDs, and then if the final standards are slightly different, then there would be new OIDs?
No, so this would hold. Sorry, go ahead, Sean.
No, I was going to say I was going to hold. I don't really want to pick any winners yet. You actually look in the GitHub repo, it says candidate 1 and candidate 2. So I didn't even put the names of the algorithms in there because I don't want to be perceived as picking a winner.
No, but I just mean, like, I guess the winners will be picked in just a few months, if I understand the NIST schedule. But the final NIST standards will take 2 years or more. So,
well, I'm hoping what I'm hoping they'll do is publish a list of OIDs that'll go with that, and then we won't have to wait for 2 years.
Okay. Yeah.
Okay, I think the way forward is Sean to figure out this key agreement thing, then post another draft. And then we will do a call for adoption.
Thank you for your time.
Okay.
And by the way, I have this red box here. So what we did is also extend the OSCORE option with a new flag bit and a field called ID detail, where we practically
Okay, Allie, I think you're doing the presenting. Nope.
Hi. Can you hear me?
All right. Hear you just fine.
All right, great. I'm Allie, and I'm going to just be talking about joint work I'm doing with Rebecca and Daphne, who are also here today, just on like a general framework that we're developing for post-quantum migration discussion. So we're excited to introduce these ideas and hear some feedback. Next slide. All right, so once the post-quantum key exchange and authentication algorithms are selected and standardized by NIST, the adoption of these into quantum-resistant protocols really depend on the progress that we make in integrating these into protocol standards. So we know there was a lot of past work put into building these in a crypto agile way. So it's important to maintain that agility as we move forward and migrate to post-quantum framework. This idea has led to a lot of recent focus on hybrid designs that use both traditional and post-quantum algorithms together. And we understand that these designs are useful for interoperability reasons or just transitional purposes during the migration. But coming from NSA, we feel that hybrid is not necessary for security, since we fully trust the vetting process of these algorithms. And we've assessed the needs for national security systems. And we really require a solution that allows for quick transition to just post-quantum protocols. So we want to focus on post-quantum only solutions as the end goal of this migration. So we view transition as a hybrid that should, hybrid as a transition that should allow for an easy move forward to strictly post-quantum. So a lot of the work so far has focused on using hybrid to ensure backwards compatibility, but we also want to ensure that they allow for forward compatibility. And by that, I mean the ability for a hybrid system to communicate with systems that prefer to use strictly post-quantum or next generation algorithms. So if the idea of this forward compatibility is built into the current designs, then the transition, you won't need a further transition from hybrid to strictly post-quantum. And this way you not only ensure that your system can interop with one that's fully post-quantum, but you also build in the capability for a protocol to be strictly post-quantum right away. Next slide. Okay, so here's just the general definition of hybrid in a very broad sense that we've seen. Basically, the security of a system is not compromised as long as at least one of the component algorithms is secure. And then there's several design choices that go along with looking at hybrid for this architecture. So again, we want to make sure that you can interop with non-hybrid aware systems. So those that are using strictly traditional algorithms and ones that are using strictly post-quantum algorithms. So that should, both of those capabilities should be there. If a design is backwards compatible, you should be able to use almost the same framework to make the design forward compatible, since in both cases, you're just telling the hybrid design, hey, only use one of these two algorithms. So if you design protocols to handle forward compatibility now, that minimizes the changes that are necessary for strictly post-quantum solutions. And again, it avoids a further transition down the road from hybrid to post-quantums, since you've already built it in. And then we also want to make sure things like we don't want to have these hybrid designs be prohibitively expensive in terms of computational performance. And then things like the time to establish a connection between peers should not increase exponentially either. So if you look at a few of the working group drafts out there for hybrid methods right now, there's a ton of different terminology being used to describe these designs. So we've seen dual signatures or combined negotiation, algorithm pairs, multiple key shares, things like that. But if you break it down, there's really mainly two approaches that are gaining traction in the working groups. And these choices fall into one of two camps, the idea of a non-composite design choice and a composite design choice. Next slide. Okay, so here's the definitions that we are using for the idea of non-composite and composite. And this is really the motivating factor of our talk today. So we feel it's really important to define this framework within the general hybrid umbrella as a way to invite a more structured discussion about hybrid designs that allow us to really make the best decisions moving forward into a post-quantum. So on the left, we have a composite design, which would be a solution in which the traditional and post-quantum algorithms function together as one entity. So that would be, for example, negotiating a traditional and PQ algorithm together as a pair. That would be composite. And then in contrast to that, we have non-composite, a solution in which the traditional and post-quantum algorithms function discretely as individual entities. So in this case, that would be like having two separate certificates, one post-quantum certificate and one traditional. So these ideas show up in a lot of different parts of a protocol, though. They're not just exclusive to certificates. So it's important to sort of introduce this framework in a more general sense. But today we're going to talk about it from the concept of authentication. So really how a hybrid non-composite authentication method would look. And we're working on writing a paper detailing the specifics of this approach, and we may want to introduce it as an informational draft to LAMPS if there's interest. Next slide. Okay, so here's the basic structure of these two approaches. In contrast to the composite design, a non-composite authentication is one where we have two separate certificates, so one traditional and one post-quantum. And again, we're looking at this under the lens that this is solely for transitional purposes. But given that lens, we want to use this structure to allow this design to use a forward transition to strictly post-quantum authentication. So the biggest difference between these two methods is really that most of the work for non-composite is put into updating the protocol to handle two separate certificates instead of just one. So most of the work goes there versus the composite approach. However, the structure for non-composite of certificate signing and verification doesn't change. The protocol just needs to adapt doing the process twice, once with traditional and once with PQ. So for the next two slides, I'll go over like the pros and cons of each design in the context of our research of how this would look in two different protocols, IETF and TLS 1.3. Next slide. Okay, so for composite authentication, for this slide, we'll consider using a composite signature and a composite certificate. So as far as deciding which algorithms to use, a composite design can really just build on the existing structure of the protocol and avoid having to introduce new protocol logic here. So for example, in TLS, you can negotiate the algorithms in a composite way. Like the client can offer a list of pairs of algorithms that it can support together, and that can be put right into the existing signature algorithms extension structure. And this also builds in the ability to match security levels between algorithms if you're using both simultaneously. However, there's a few downsides. So first, you'd have to define new composite OIDs or group identifiers to describe the pairs of algorithms together. So in essence, your protocol really has to support three types of identifiers: the traditional, the hybrid, and the post-quantum. Again, because we're thinking about this as the most straightforward design that allows for the protocol to be forward and backwards compatible. The next point, we won't get into too much detail, but the validation process for composite signatures is different from the validation process for just a single signature. All right, then there's some questions regarding deprecation of algorithms. So what happens if one algorithm in my composite gets deprecated? Since it's composite, you either need to revoke the entire certificate or revoke the deprecated algorithm. And then this opens up questions into how you handle root certificate authorities and cert chains. So like, is the whole chain composite? And what happens if one gets deprecated? Things like that. The last point then is regarding the transition to strictly post-quantum systems. So if we move forward with composite authentication, it's not very straightforward with regards to backwards and forwards compatibility. So how do you drop one of the two composites to a non-hybrid aware system? And it's really important to maintain that interoperability when we're going to backwards and forwards to just post-quantum. So essentially the hybrid composite approach requires implementations to possibly face another entire transition period from the hybrid period into just the post-quantum period. And we'd really like to avoid that and use the hybrid as the transition to post-quantum. Next slide. So then the opposite of that would be the non-composite approach that we're looking at. So there's several differences here from composite. So first, the computational process for validation doesn't change. You just have to do it more than once. So this will probably work different for chems and stuff, but that would affect the composite design as well. So this does, however, result in logistical changes at the protocol level. So if you think about it, in IETF112, you'd need like a new notify payload to be defined in the IETF init, and that would signify support for composite authentication. And then sending this payload would indicate that your implementation is going to support two sets of cert requests and authentication and cert payloads, where one would be for the traditional algorithm and the other one would be for the post-quantum algorithm. There's a similar story that happens for changes required in TLS 1.3 to implement non-composite. However, in the long run, if the goal is a jump forward to strictly post-quantum solutions, making these logic changes now allows them to be forward compatible and strictly post-quantum ready right away without a further transition. Using two separate certificates also makes it quite easy to be compatible with non-hybrid aware entities. So the same signature algorithm OIDs are used in a hybrid as they are for a traditional system and a post-quantum system. And then if you have support for one or the other, the unsupported certificate just won't be sent, right? So for example, in IETF112, only one set of cert requests, cert and auth payloads will be sent that indicates a non-hybrid status for the client. So overall, this design allows for broader crypto agility since you're really just using the same sets of algorithms and no new set needs to get introduced. Also for cert chains, this is straightforward. So the non-composite approach, it's really just a matter of a policy update to support more than one because it'll use the same root certificate authorities and the chains are unchanged as well. All right, next slide. Yeah, so we're really just looking to get feedback for this on the list. Like I said, we have sort of an informational draft in the works that gets into the gritty details of how this non-composite authentication design looks. And then we have a more technical report where we look at the details of this in the lens of two different protocols. But overall, we really just want to introduce this hybrid terminology of composite and non-composite into LAMPS and maybe into IETF as a whole to use this as a framework for post-quantum migration. And that's all.
Okay, DKG, then Joe Salloway.
Hi there, this is Daniel Kahn-Gilmore from the ACLU. Thanks for this presentation. It's really useful to see the kind of framing that you're talking about. I wonder if you have any thoughts about how this would map to, your analysis I feel like is very specific to authentication here. And I wonder if you have any thoughts about how this maps to key agreement or encryption schemes.
Yeah, I think that this framework of composite and non-composite can definitely be used for key exchange as well. It's not just for authentication. So I think in some of the working groups like TLS, their hybrid approach right now is a composite, using composite negotiation for key exchange as well. But you could use this idea of non-composite there too.
Sorry, I don't think that TLS is doing key exchange right now. TLS is doing authentication, right? These are, modern TLS does signing of the separately Diffie-Hellman negotiated key agreement.
Oh, yeah, I was talking about, there's a hybrid draft in TLS that's looking at for post-quantum migration, how that would work.
Of the analysis that you presented, you seem to have a lot more pros on the non-composite than on the composite. I'm wondering whether that analysis applies to, whether you think that the analysis you've presented here applies to key agreement schemes in addition to applying to authentication schemes.
Oh, yeah. So our pro-con list is mostly looking forward to what structure would make it easier to move to just a post-quantum framework. So yes, this does. There was not, just authentication specific, but we were using that as a framework for today's talk. Yeah.
Okay, Joe?
Yeah, so similar question to Daniel's. And just to comment, I think it would be useful to kind of go, because I think the key agreement hybrid structure is going to be a little bit different than authentication, because at the end of the day, I think you need to end up with one key or some shared secret. So I think there's some differences. So I think it would be good to, if you think this is going to apply to key agreement as well, which makes sense that it would, but I think it would be good to go through some of those pros and cons lists and kind of the analysis specific with key agreement. Thanks.
Scott?
I already talked to the TLS working group of at least some people in there, and they really want to go with non-composite certificate design because basically, they don't want the bandwidth, use up bandwidth for something for a legacy client, which doesn't need these huge post-quantum signatures public keys. What I'm taking back from that is maybe this is not something that the LAMPS should decide, but it's really something that the working groups need to decide, and LAMPS needs to maybe needs both options out there.
Beginning to think that myself, Scott, so that we need to give both tools to working groups to implement or to pick from in their protocol environment. Mike?
Couple of comments. First, Scott. So I've been viewing the composite stuff as existing within a multi-cert environment. So I'm imagining that you'll provision your TLS server with an RSA cert and separately an RSA plus PQ cert is how I've been imagining this composite would get used. And if you're already sending a PQ public key, slapping an RSA public key into the same object for, good measure is nothing in terms of bytes on the wire. So I've actually been imagining that composite exists within a multi-cert framework for exactly the don't send it if you don't need it reason. I don't know if that's commensurate with the discussions in TLS or not. Second, while I have the mic, and I'm about to present right after this on composite, but Ali, thank you so much for this framework. I think this is really, really useful work. Comment I'll make, so I think speaking for myself, not for all the authors here, but I think I fully agree that for online negotiated protocols, IETF, I think I totally agree with your analysis. Multi-cert gives more negotiation flexibility, yada, yada, yada. I think that's great. Where we keep getting stuck in our own internal design sessions is the offline protocols, code signing, SMIME, those type things where you're signing objects or you're encrypting payloads and you're just firing them into the void and you have no idea who's going to pick them up. That's the cases where we just haven't found a way to make multi-cert click. If you get an EXE and you're an EXE running framework and you're validating the signature on that EXE, how do you know that there were supposed to be two signatures on it? How do you prevent that stripping attack in a totally offline, non-negotiated? So I would love to see your framework also address offline protocols, possibly completely separately from online protocols.
Okay, I think that's a good suggestion.
Bro?
So I was commenting about the IC version 2. IC version 2 is actually not defining at all for authentication. It's only doing the agreement currently. because we see that the authentication is coming from us to us from PGIX or something like that. That we just use the certificate and hope that everything works. But in our key agreement, when we are doing non-composite method, we do separate rounds, and each of the round is actually finished before the next one starts, and each of them actually updates the keys that are used for the future rounds. And the first round is always going to be traditional Diffie-Hellman, and we are not going to go away from that. I don't think so. And the reason being that it actually provides us quite good security in a way that we actually know that the person we are talking at that point is going to stay same. So it gives us this kind of continuity. And I don't think anybody's going to have a quantum computer that can break Diffie-Hellman in seconds, which would be required to be able to break this kind of, because the Diffie-Hellman is only used to protect the next 10 messages or a couple of messages after that. There is also one of the things that we have been seeing that people have been complaining about, because some of the post-quantum methods the keys are big, and we don't want to do that before the authentication or some form of authentication. So we have also a way of doing, we do a couple of rounds, we might do a Diffie-Hellman first, then we might do an authentication with traditional, some method of doing authentication like a preset key. And then we could do some more, post-quantum key exchange, key agreement methods to actually, which are then protected by the authentication done by the preset key. And the preset key is actually post-quantum safe, provided the preset key is itself, or PPK, is strong enough to be protected. So it's a little bit different. It's not completely non-composite, and we are never actually probably going away from the original Diffie-Hellman, because that's so fast and it only provides the security for the next few exchanges after that.
Yeah, I guess I'll just say that these ideas definitely show up in different areas of the protocol. So it's not just in authentication. And I know IKE v2 has, specific things set up for the intermediate exchange and things like that to handle this. But I still think it's a nice general framework to have when discussing it.
See that the queue is empty. Allison and your co-authors, thank you. I heard a lot of interest in the chat for a paper, so I hope you will do that. And I heard suggestions that you had a store and forward based protocol to your analysis. Okay, so the last presentation was the one that Mike already alluded to on composite. And so Mike, please come to the mic.
Hello. Okay. Aware that I'm the last thing in the day, I will try and move quickly. This is sort of a grab bag of different stuff, because we're involved in probably 6 different drafts at this point, which I've now got less than 20 minutes to power through. So, go. Next. So I've sort of 2 different bags of topics here. One, I'm going to throw a single slide about the work that I've been doing with the guys at CryptoNext. So that's not composite at all. That's just trying to figure out how to do the plumbing work to fit a chem into a CMS, content encryption, enveloped data. So I can just do a single slide update on how that work is going, since it hasn't been to the mailing list yet. And then into the meat of composite, where we're at, updates. Allison's presentation was a good load of information, so I'm curious to see if any of this shakes out, becomes unnecessary, wants to be rewritten, given that analysis. I think it's, we don't have any horses in this race. We just want to see the technology move on. So that's amazing that NSA is stepping up to give guidance here. Hopefully that will help to settle some of these design decisions. Okay, Next. So this is a draft primarily authored by Ludovic Paré and Julien Prat. They didn't sign up for a speaking slot, so I'm taking this for them. Chems. Chems are a different structure, structurally different from either a key trans or a key agree. I mean, you can sort of convert one into the others. You can convert either a key trans or a key agree into a chem pretty straightforwardly, but it's a slightly different API. So I like to think of a chem like a Diffie-Hellman sort of key agreement, but there's only a single public key involved. So your sender does not have a public key, only the recipient has a public key, but otherwise works the same way. You take the public key, a shared secret falls out, and a ciphertext falls out. So you don't get to choose the content encryption key. You're just given a shared secret, which is a slightly different API. So the question here is, how do we fit that API in? And one approach is to generalize what RSA Chem 5990 did. They decided to turn it into a key trans and publish a key trans external API. And that's the way Ludovic and Julien's draft currently is written. The other option, although that's the weirdity there, is that you need an algorithm ID that says, actually, I'm not a key trans, I'm a chem. And then you need to see algorithm params, which I think has been hissed at already here. You need algorithm params on that dummy OID to say, actually, I'm a chem, and actually, here's my chem, and here's my KDF, and here's my key wrap, which is a little weird, especially because I know some other RFCs reference, allowed encryption algorithms for CMS, and so now you'd have a allowed encryption algorithm, which is the generic chem dummy OID. So it's copying what RSA Chem's done, but it's a little weird in some places. Other options are to use the other recipient info, which would have content similar to one, but probably semantically clearer that this isn't actually a key trans. The third option is we define a new top-level recipient info called chem recipient info. That is basically the recipient info as defined in 4210 as a choice of key trans recipient info, key agree recipient info, password, KEK, other. We'd be adding a sixth element to that list. And so I think we'd have to look carefully at whether that is a backwards compatible change or whether that would require a rev of the version number of CMP, which I think is probably unacceptable for a change this small. If we can safely add an element to that choice list, then that might be preferable. Otherwise, one or two are a little kludgy, but probably more backwards compatible. So Russ, I don't know if we could take a straw poll or a hum or something. Is the question here, is this a significant enough design choice to be worth a full-blown discussion on the list, or are these all sort of equivalent and we should just write one up and submit it as an OO?
Well, I'd like to make a few observations. Then, if people want, we can do a show of a straw poll thing. The observation I would share is that the biggest difference in the CMS structuring between key trans and key agree is the single public key or two public keys. And so given that the KEMs have one, I kind of lean naturally towards, let's see if we can use it. I don't think we end up necessarily with parameters if we assign OIDs that say, use a particular KEM with a particular KDF with a particular wrap. We end up with a lot of OIDs that are very specific, but no parameters. So I don't think picking at that level guarantees the complicated parameter structure. It's a trade-off.
That's sure. You can always unroll params into a huge
exactly.
Yeah.
And that's what that's what we've seen in the TLS environment, them doing more and more because we want to avoid strange parameter interactions. So does anybody disagree with that? Who would like to come to the mic?
So you're, just to be clear, you're proposing that key trans with unrolled OIDs is
Yes,
the
that's
preferred
exactly
approach
what
here?
I'm proposing. Your face says you're thinking.
Sorry, a reflexive beard touch here.
All right, Joe, go ahead.
Question would be is with respect to calling this key trans, does that have any implications of like, well, key trans I usually think of, I'm using the public key to do encryption of some sort, and not all chems you're really doing that. Does that have any implications further down the line, or is this just a naming issue?
I think
the big implication is it has to have one public key.
Can I take that, Russ?
Sure.
So I've got the core idea of this draft is sort of sketched out on the side there. So the idea is you use the chem to derive a shared secret, you use the shared secret to derive a KEK, you use the KEK as an AES key to wrap the CEK. So you are in fact encrypting. And we've, because of that KDF, we've KDF'd out any particulars of the chem you chose. So I do think it's actually fair to call this construct on the side a key trans? Question mark. Hopes for agreement?
So I agree. I agree. It's not key agreement.
Key. Did I say key trans?
Yes. But you asked for agreement with your statement. John, go ahead.
I was just thinking, because I've thought a lot about this too, but I like clean implementations, and the fact that there's going to be a lot of chem is happening a lot more, right? Like all the PQ algorithms, a lot of them are chems, and RSA obviously is a chem as well. So does not having its own recipient info kind of alludes it to its own family of algorithms. So I think in that way it just seems clear, like semantically it seems clear, at least in my mind. So yeah, I know we can make it fit into the key trans, and it has been done, but is there an issue for semantics to just not have its own chem recipient info, or is it a big issue with, we think it would cause incompatibilities if we were to add a new recipient info type? So I guess that's where my thinking is on that. It just seems semantically cleaner, and it seems to be the way forward with these new algorithms that are coming. So.
Hi. Yeah, I also I think that that the other recipient info direction would be better. Like if we choose key trans recipient info, we're kind of locking in that we don't have the flexibility that key agree recipient info had for including optional user keying material. Whereas if we did allow have a new structure specified by other recipient info, we could add that if we wanted it.
That's a good point. The UKM field. Go ahead, Sean.
This not knowing the answer, is this leading us down the path of trying to say to specify another key usage type in X509?
This is what I alluded to during your presentation. Was the exact?
Yeah, okay. You were, so I did read the tea leaves. All right. So I guess my question is, how much of a absolute PETA is that going to be? And do we think there's any chance that will get implemented in any kind of timely fashion by both, CAs and relying parties?
I don't know that we need a different KU, but which KU we're going to support here, I think, is relevant.
All right. Thanks.
It's pretty clear to me this is a big enough decision. We should take it to the list. I do think opening CMS, which is a full standard, does mean that we need to think pretty hard before we do that. But if it's the right answer, it's the right answer. And I hadn't thought about the lack of the UKM field. Right. Next slide, I think. We've got about 10 minutes.
Perfect. Let's go. Okay, so the back half of my presentation is basically this slide unrolled into sections. In the interest of time, I could probably do it all off this one slide and leave the rest as an exercise to the reader to go find my full slides. So this is just sort of an update on where we are. So there's been a lot of work done by our author group here against these LAMPS milestones that are probably still sufficiently in the future that I don't know that the working group is ready for nitty details, maybe, question mark. So once again, I'll present a landscape. I've structurally chosen to break the dual composite hybrid stuff up by keys inserts, signatures, and encryption. I think they are sort of structurally separate. So in the keys inserts, there's our 2 drafts, composite keys and explicit composite keys. I put a nod here to Ali's presentation because at time of writing, I wasn't sure if it was going to be a concrete proposal or a framework or, but I'm really not aware of any other work in this sphere. At the interim, it was suggested, the interim we had in September, it was suggested that explicit, if we are going to go with composite public keys, explicit pairs of voids is preferable to a generic container, and that's consistent with the no params, let's unroll everything discussion here today. So I think that's well received. So we'll probably end up dropping the composite keys draft and go with the explicit composite. The ASN1 is turning out to be a bit of a bear. We're trying to use the new object class structure so you can just factory out pairs of voids super easily, but we're really struggling with some of the details there. Could you flip forward one? Thank you. We have a plan to still support generic. So if you need something that doesn't have an explicit OID, although maybe that's not a use case we should care about, but if that is a use case you want to use a pair that doesn't have a defined OID, we could register an OID for PK any with any, which would be an explicit pair, but open, if that nomenclature makes any sense. So there is still possible to make a generic OID within the explicit framework. Yeah, the bottom half of the slide was well covered by Ali's presentation. Yeah, don't do that. All right, point taken. Yeah, well, I guess we'll have to see how much, if there's interest in generic at all, or we think it's, do people need to go off-roading outside of the established pairwise OIDs? Do we need a generic at all, or is it fine to put up fences on that road? You must use the established pairs of OIDs. Any with footgun, yeah, fair enough. Okay, interest of time, signatures. Haven't really done any major work on this in a while. I think it's sitting fairly mature. We do have some design decisions that we'll bring up if and when the working group adopts this, but it hasn't really been worth chatter on the mail list yet. We also can make this explicit. Currently, it's a generic structure. We can also come up with ASN1 modules that allow you to define explicit pairs of SAs, signature algorithms. I will point out that if we decide to go multi-cert and we need a way to stuff a multi-cert single signature, so if you have multiple certificates generating a single signature, you're still going to need a container of some format. And so we believe this work is still relevant even in a multi-cert world, unless protocols really do want to carry a second signature field everywhere. So again, my choice to present this as separate from the public keys is because I think this survives a multi-cert draft, or is still useful in comparison with a multi-cert draft. Yeah.
Mike, I agree with you in some environments, but not CMS, right? Because signed data allows multi-signatures.
Yeah, that's a nuanced, because signed data sometimes implies that that's an OR. relationship?
There's already a document that provides an attribute, whether it's an or and.
That's
but
right.
That's a
yeah.
Right.
Right. Okay. So there is a mechanism we could tie in to clear that ambiguity. Okay. Okay. Next. The font's a bit small here. So the last piece of work we've been doing, this is where we've done most of our work in the last 6 months, is composite content encryption for CMS. How do you say you come across a recipient who has multiple public keys? Again, I don't particularly care whether that's in a single cert or whether that's across multiple certs, but you have a recipient who declares that if you're going to encrypt for me, I'd like you to use multiple public keys to do it. What does that envelope data look like? We've put out an OO. I think we proposed 3 completely different mechanisms in that OO draft. We're still working on that quite heavily. I think we've found a way to combine all of them nicely together into one single mechanism. We're debating here also the key trans versus chem debate. What is the external interface that this should expose? This is probably going to couple into Ludovic's draft. We'll probably make composite encryption expose a chem type, and then it'll fit into whatever Ludovic comes up with. Although you could also imagine it exposing a key trans, and then it can go straight into key trans recip info. There's also debate over what the underlying mechanism should be and how that should function. Should it be sort of based on a one-time pad XOR for wrapping the CEK, or should we throw in an AES key wrap layer? That decision sort of will dictate the key trans versus chem decision. So this one's still, it's an OO, but it's still, I think there's still a lot of design decisions to be made here. And that's the end of my slide deck, with a whopping 4 minutes for discussion and wrap up.
Anyone want to come to the mic? John?
I was just going to add to what Mike said. He mentioned the composite chem. So we're actually thinking about creating a new draft just for a composite chem construction, because we, as part of our debates for the what he was just talking about, composite encryption, we came up with the idea that perhaps it's just simpler to have a composite chem construction, and then if there was such a thing as like a chem recipient info or just a chem usage type, it just fits in there much better and it seems simpler. So you might see us request a 0.0 draft for a composite chem, because I think it'll be I think it's separate enough that it would be worthy of its own draft. So I just wanted to point that out.
I guess stated
differently. I'm not sharing my picture. Sorry.
I guess stated differently, what John just said, if the composite chem draft is already going to define how you do the KDFing and the AES wrapping, then great. We can just provide the chem part.
Yeah.
All right. Given that we're down to 2 minutes, anything else?
As always, direction here would be lovely. I feel like we're trying to solve these problems with very little input.
Yeah, I think that you should start a few threads, on the higher order design decisions, and maybe see where they take you, and then we'll see when we get to a point where we can adopt a document after having a few of those design level discussions. Does that make sense?
And one of those discussions is the one you alluded to. Is any of this work necessary? Do we have use cases that we're going to want composite and dual atomic structures?
Exactly. Right.
Is actually a question I don't know the answer to. If so, we've got one, but is anyone going to use it? Question.
Okay. Well, so this has been a very interesting and diverse session. So thank you, all of the presenters, and we made a whole bunch of Action items. Thank you, Deb, for taking the minutes. Appreciate it. And so I think this is the last session of the day. Thank you all, and we'll see you next time, and we'll see you on the list. We have a few things to deal with on the list, like the EKU document, immediately. So thank you. Be well.